How do you answer questions about the development of the periodic table and not get bored stiff? Here's a suggestion. Roll that graphic. Hi, I'm Paul. This is Science That Sticks. In this episode, I've been holding off on this one for quite a while because I'm not being sure how to do this. So I've decided that I'm going to put in a few characters behind me. Now, one of the things that you know, because your teachers have told you, and I know because my teachers, the people that have taught me at university and college, and I've seen it in textbooks, is the fact that I know about electrons, neutrons, and protons, and you know about electrons, neutrons, and protons. And this is 2025. When these three people lived, it was the 19th century. They did not know about protons, electrons, and neutrons. So when you're answering a question about the periodic table, the development of the periodic table, don't start talking about protons, electrons, and neutrons unless you're asked about the modern periodic table. Let's have a look at what these three guys did. So our man Dobereiner here, he puts them in order of weight like many people did at the time. So that's nothing particularly special. But he noticed that if you could put them into elements of threes, triads, that react very similarly. So that's what he's famous for. He put them in threes, and those were called the triads. Now, Newlands, our man Johnny Newlands discovered that if you put them in mass order, because they didn't know about atomic order, because they didn't know about protons, and neither did he and neither did Mendeleev. We'll come back to him. There's a reason he's bigger than the others. Now, he noticed that if you put them in atomic mass, every eighth element reacts very, very similarly to the 1/8 before it. So he comes up with this idea of the law of octaves. And we kind of still add a bit of a nudge to that with the electrons in, maximum of 8 in the second, maximum of 8 in the third shell. Of course, it falls down with A level, but let's not get bogged down in that. Now, a man Mendeleev, however we want to call it, Dmitri, he's bigger than the rest because he's actually on the periodic table. He's got his own element named after him. Now, you can't be slack about this. Okay, this guy knew his chemistry. Not only did he know his chemistry, he did agree that you could put them in order of mass, but this was not the definitive way of actually putting things. He lived in a time where in his lifetime there were more elements being discovered almost on a yearly basis than there had been in the previous 1700 years that people have been doing any sort of science. And he really got down into the nitty-gritty with the reactivities, with the physical properties, the chemical properties. What did they react with? What did they not react with? And he knew his stuff. And he put them all in order, and he left gaps. And in them gaps, he predicted the properties chemically and physically of those properties. And the dude was right. Not only was he right, he predicted those orders, but he left gaps because he knew that they had not yet been discovered. That's one of the smartest things any human ever did, which was to realize, hey, maybe we don't know everything. Good for him. But that's not where it ends. He does one more extra really cool thing. He predicts all of those things, but then with some of them, where he needed to, he actually swapped them around. So if you look at tellurium and iodine, they're next to one another in the periodic table. You could go and have a look at this in your own periodic table, and you'll notice that tellurium has got a mass that's higher than iodine's. And most people have put that the other way around. Mendeleev decided, I'm going to separate those two out. I'm going to put the iodine in with the others that react in a similar sort of manner, the halogens. He does so. Once those predicted elements that he predicted were found, and the data that he suggested that they were and predicted that they were, both chemically and physically, were identical, he was taken very, very seriously. And the modern periodic table was born. It was also deeper than he knew, because when we discovered protons, neutrons, and electrons, we discovered about electrons in orbitals, certainly in the very early 20th century, in the very late 19th century, with our boy J.J. Thomson, Chadwick, and Niels Bohr, all of those three alpha scattering particles. Nothing that I want to get into here. But now, they discovered that not only was the atom actually a nuclear model, not a plum pudding model, he was able to also identify that most of the mass was in the center, which it is. Most of the nucleus is positively charged, which it is. He discovered that the electrons, well, Mendeleev didn't, but these other fellows, they did this, and they discovered that the electrons were particles themselves. Now, the really cool thing, the really cool thing about all of this is that the protons that are in atoms designate the kind of atom it is. Wow. He didn't know about protons. So when you answer a question about Dmitri Mendeleev, you can't say he knew about the proton order or the atomic number. No, he didn't, because it hadn't been discovered. Neither did these two chaps. Don't say that. But when it talks about the modern periodic table, then you can actually say, the modern periodic table is ordered in atomic number. The groups indicate how many electrons are in the outermost shell. Okay. Not only can you do that, but you can also then talk about the shells. But you can only do this when the question specifically asks you about the modern periodic table. Prior to that little bit of statement going on, Dobereiner, Triads, Newlands, Law of Octaves, the eights. Mendeleev, he recognizes that I predict and I'm going to order these elements and I'm going to leave spaces, and in those spaces I'm going to predict the chemical and physical properties, and that's exactly what he does. You can slow this down. It'll take you twice as long. That's my best advice to you all. Until next time, stay cool. Bye-bye.